The winds that blow from the horse latitudes toward the equator are known as the trade winds. They follow the ground level flow of the Hadley cell. But they don't blow straight toward the equator. The Coriolis force bends them. These winds blow steadily at about 11 to 13 miles per hour and were well known to early sailors because they provided a reliable, quick sailing route.
Arr! Me likes these trade winds. Brock!
The trade winds from the northern and southern hemispheres collide, pushing both columns of air up. The rising air cools and forms clouds, causing frequent storms with lots of precipitation. There's not a lot of horizontal air movement where the trade winds collide because the wind is primarily rising. Early sailors recognized that this area, named the doldrums, was not good for sailing and avoided it. Winds leave the high-pressure horse latitudes in both directions, as well as blowing toward the equator. They also blow toward the subpolar low in a wind pattern called the Westerlies. Like the trade winds, the Westerlies are deflected by the Coriolis force, but since they initially blow the opposite direction, they bend to the east.
Polly, why are they called the Westerlies if they blow east?
Comes from the west. Rock!
At the pole, there is a high-pressure region called the polar high, which forces air south toward the subpolar low. These shallow and fairly weak winds blowing away from the pole are called polar easterlies. As with the other two winds, they get deflected by the Coriolis force. The trade winds, westerlies, and polar easterlies are the major wind patterns on Earth, governed by uneven heating and the Coriolis force. Land masses thrust up into these winds and scramble them up quite a bit, which makes it difficult for weather forecasters to predict winds and the movement of storms.